Okay, good morning and welcome. It looks like we're at the top of the hour this morning. I'd like to welcome you here for our introduction for hot O2 monitoring. We call it our O2 track. And going to be a lively discussion today. All of my slides are numbered in the lower left-hand corner. This is open forum. We can have everyone unmute themselves and ask questions as we go forward. I think we've got a lot to discuss here. I'll go ahead and hide my camera. There we go. And a little bit about sustainability. It's a corporate, really a way of life for us to talk about sustainability, and that we're going to continue to build better products. And once we build those better products, we're going to integrate those into more sustainable systems. So with that, we can look at reducing emissions. So this is not just a couple of buzzwords. This is a way of life for us here at the Rheem Commercial Water family now. And so with that, we'll kind of get started here for the bulk of the presentation. I would like to welcome Bob Ellis. Bob Ellis is a regional sales manager. I've asked him to speak on a few slides pertaining to the sales protocol and things we have in place. Bob, go ahead.
Hey, good morning, Raypak Nation. I'm excited to be a part of this introduction of our O2 Track Go Live. As you can see, the O2 Track is currently live and available on our XVers+KOR. Paul is going to explain more about what that is, but suffice it to say that it's constantly monitoring the oxygen level in the flue so that you can see what's going on with your combustion and look at the overall performance of your unit. We are going to be stocking the O2 Track on all of our core units in our 3PL warehouses throughout the country as our current inventory depletes. So it will all be replaced moving forward with units, core units with the hot track. There is going to be a retrofit kit available for this, so that if you have one installed currently, you could actually retrofit it, or if you pull one out of the warehouse and you want the O2 track, that's something that could be field installed. It will, on configured units, it's going to be optional. It's going to be our C13 option, and it will be an optional feature that you can select in X-ray. Oh, there we go. So some of the key changes going forward as we have released now the O2 track. XVers+KOR key changes. You're going to notice that we've got the O2 track monitoring available as an option. Biggest changes that you're going to notice is that when you're in X-ray, we've taken as a standard feature, we've removed the suction diffuser and the flow switch. So those are selectable now. Those are items that you would have to choose. They won't be standard in the standard features. So I want to say that very clearly to you. They are now going to be optional features. And the reason for that is we found that it, in some cases, was to our disadvantage. The suction diffuser, there were times when people did not need it, and it was because it was a standard feature, it added to the cost. So we have chosen to remove it and made it selectable. And then also the flow switch. You might think, wow, you know, you need the flow switch. Well, it's a high mass fire tube, so actually the low water cutoff is more important in that regard, the safety, and it's because it's less flow sensitive. We actually it can be to our disadvantage, and we aren't able to take advantage of the full range of flow that the XVers+KOR is capable of, because the flow switch sometimes will trip before we reach minimum flow in the unit. So this allows us to take full advantage of the full range of flow that the XVers is capable of, giving it the maximum flexibility. So if you feel you need a flow switch, you can add it as an option, but it will be optional moving forward. So just as, to reiterate what's going to be in our 3PL stock as far as XVers+KOR, you'll notice in the sizes from 1 million BTUs to 4 million BTUs that they will have the O2 monitoring is standard, the C13. They will have a manual reset auto adjustable limit set for 200 degrees as also standard, have an auto reset limit set. That's part of the ignition module, that I13 200 degrees standard. And then of course the high and low gas pressure safeties. Those are all standard features, but probably the biggest change to stock at the 3PL is going to be the fact that they won't have flow switches, they won't have suction diffusers, and they will have the C13 O2 monitoring. So as we move forward, our resources have been upgraded. You'll notice when you look at our new submittals and manuals, the portfolio will be updated with all this information regarding the standard features as well as the O2 trim. Not the O2 trim, my mistake, O2 monitoring. So the specifications, and then there'll also be field upgrade kit instructions. The sales presentation has also been updated along with product comparison and playbook. So there's plenty of resources for you available to help you present this to your customers, and also for you to take a deeper dive and understand the product. With that, Paul, I think you're going to actually do the deeper dive and share what this is all about.
Great job, Bob. Thank you. I really appreciate you jumping in. And of course, we'll do Q&A as well. If anyone has any follow-up, I always encourage you to reach out to your regional sales team, and we'll make sure you have all the tools you need. So again, thank you, Bob.
You're welcome. And Raypak Nation, have a great day. Enjoy the presentation.
Okay, well, good. Moving forward, what is O2 monitoring? Why is it important? And I like practical things. And where I live in the Midwest, this past year, we got pretty darn cold. I live in Nebraska, so between Lincoln and Omaha, and we got down to -13 ambient, and that wind chill on that middle image right here, we got down to -40 wind chill. It was what we call in the business darn cold. And as it turned out that day, my daughter said, "Hey, Dad, my check engine light came on her little car, on her, as she was heading off to school." It's like, okay, let's take a look at it. And thankfully it started, number one. But then I put a little OBD tester, and OBD is onboard diagnostics. Since 2005, all cars, it's mandatory that you have that OBD port. So this little $35, $40 tool, I plugged it in to the check engine, or to see what that check engine light was, and the error code that came up said that it was too lean. And this is a really good baseline for us moving forward for O2 monitoring, which we call O2 Track. And then here in the very near future, we're going to talk about track and trim, where we can actually make adjustments. But as it pertains to O2 monitoring, the cars all have O2 sensors. And when that air is so cold, it is very dense. And that very dense cold air can accept more fuel. Well, for that reason, since it could accept more fuel, it was running very lean. And that was the error code that came up on her car. Now, we'll segue back to this here in a minute, where this comes into play. And we'll talk about combustion, because when it's really cold outside for combustion, it's going to manifest itself in a couple of different ways. When we have that very cold, dense air, and it can accept more fuel, you'll see a little bit of change in the combustion, and you'll see an increase in O2, right? And then as it gets warmer outside, you'll see that increase in air temperature. You'll see a little bit different personality or characteristics of combustion, and you'll see a decrease in O2. So knowing what is going on, as Bob mentioned earlier, is going to be important for the health of the combustion in that boiler. Now, as we talk about combustion, we take a little bit of air, we take a little bit of gas, we mix it together, and from there we ignite it, and then we can extract heat. In perfect combustion, there would be no byproducts. You take the precise amount of air, the precise amount of fuel, we extract the heat, no byproduct. Well, that's perfect combustion, and that's theoretical. It doesn't exactly happen that way. Likely that we're going to have incomplete combustion, right? And incomplete combustion is we're going to have a couple of byproducts in the flue gas, in the exhaust, that we can monitor, that we can look for. And this is the foundation for which we're going to move forward with O2 monitoring. So in the spectrum, let's say, if we talk about perfect combustion, that's called stoichiometric combustion. And again, it is theoretical. It is a practical impossibility. And our combustion engines right now in our high efficiency appliances, our ideal operating range is just a little bit on the lean side, where we have a little bit more air than fuel. So that is where we want to live in this bandwidth of proper combustion. Well, as we said, once we ignite, we're going to have some byproducts, right? We can measure CO2. We can measure O2 with the O2 sensor now. On the rich side of combustion, it's going to manifest itself by seeing a real spike in carbon monoxide, right? So these basic ingredients all come together, and as that boiler operates, it's also going to give us our rated efficiency, right? So we look at this holistically from a 1,000-yard overview, knowing that we are not going to be at that perfect level of stoichiometric combustion. We're going to want to be in the ideal operating range, slightly across that border into our ideal operating range, a little bit on the lean side, okay? So here's where we get into the specifics of O2 monitoring moving forward. Truth be told, and we'll show a picture of a combustion analyzer here shortly, combustion analyzers are fantastic tools, and a combustion analyzer can measure CO2 at high fire when we're dialing in that proper combustion. Well, truth be told, there isn't a CO2 sensor in that analyzer. It's actually an O2 sensor that is utilized, and then it extrapolates, it diagnoses then what that CO2 reading is. So we're measuring O2, we're converting it to CO2, and from there, we're dialing in our combustion with our combustion analyzers, right? That's pretty common for us. What's important to know is that on either side of that spectrum, when we're dialing in proper combustion with our analyzer, we can see the same CO2 reading, both on the rich side and the lean side. You can just see how that would function. So how do I know? Well, if I'm on the rich side, it's going to manifest itself by seeing that real high spike in carbon monoxide, right? On the lean side, I might see a more an O2 reading, my oxygen reading, more in line with being on this lean side. So there's going to be some real prominent tells, if you will, that we're looking for this proper combustion. And this now is our key for unlocking proper combustion with our analyzer. We're going to look at that CO2 reading, and we're going to know immediately with the byproducts of oxygen on O2 or the byproducts of carbon monoxide on which side of that spectrum we have. Well, that's with our combustion analyzer measuring CO2 on high fire. Now, with the advent of this O2 sensor, now we're going to get a very precise reading that we're going to be able to verify, and we're going to be able to contrast that O2 sensor reading to that of our CO2 on high fire. So again, as we said, we're going to know immediately if we're on the bad side of combustion, because you're going to see that excessively high spike in carbon monoxide, right? Carbon monoxide is very bad. It can have a cumulative effect. Once that carbon monoxide, what it does, it robs the oxygen out of your bloodstream, and it's of course very, very deadly. It's very dangerous. So we want to mitigate that and get to that proper levels of combustion. So having an O2 sensor used in conjunction with a combustion analyzer to verify proper combustion is what we're going to be discussing moving forward. And of course, we know these basic ingredients, you know, as our commercial training team goes through our wages presentation, water, air, gas, electrical, we know what our air pressure is. Once we get the unit to fire, we get that fan speed up to 100% of its rated capacity, we can put a manometer on there per model size and see what that manifold reading is, right? We know that it's something that we verify against in our manual. Right now, what you're looking at on the lower part of this slide is our standard altitude units. And of course, for those in higher elevations, the high elevation units are going to have a little bit different reading, right? But these are the basic ingredients for the air side. From there, we're also going to look at gas and the manifold gas pressure. And once we have those proper air manifold pressures and proper gas manifold pressures, now we're really, you know, I would suggest setting ourselves up for proper combustion very, very easily. And we cover this in our training at the factory. It's not going to be a time you're going to want to go ahead and do a combustion analysis until you get the basic tenets of manifold air pressure and manifold gas pressure, as well as static and dynamic gas pressures as well. So once we get all those basic ingredients in their proper ranges, only then do we move forward and start looking at CO2 on high fire for that proper range of combustion. And again, this is a percentage right here, okay? Here's an example where on this particular combustion analyzer, I was at 9.2% CO2 on high fire. And at that point in time, the O2 reading was 4.6. So again, it's a correlation of and a byproduct that the oxygen sensor in this combustion analyzer extrapolates and tells me what that CO2 number is at high fire. But now moving forward, we have the addition of an O2 sensor, an oxygen sensor, and we'll show it where it's going to be located. But this is what the screen is going to look like right here in this middle, right? And in our manuals now, we're relaunching the XVers+KOR. And that XVers+KOR, as Bob Ellis suggested, if it's a stock item in our 3PL, it is going to have an oxygen sensor mounted in that exhaust stack, which we'll talk about here shortly. And then we can compare and contrast the oxygen sensor reading, the O2 reading, at both the screen on the computer as well as on our combustion analyzer. And it's going to be normal to see some slight variation. So more on that in just a little bit. But of course, now in our manual, as we've updated and launched this product, we now are going to have the O2 readings for high fire per model unit for both natural gas and propane, as well as the O2 reading at low fire. Okay, so it's all going to be just like you have done in the past, but now we're also verifying O2 as a reading, whereas previously maybe you were focusing more specifically on CO2 at high fire. So again, there's going to be a little bit of a difference here, and you can, even though this is O2 monitoring, you're not going to make a change to the combustion engine. But let's say, for instance, that you had a slight variation from your combustion analyzer reading to your O2 sensor on the boiler plant. It's going to be very normal. There's a lot of different manufacturers of combustion analyzers. We have Testo, we have Fieldpiece, UEI, Bacharach. There's a lot of very good combustion analyzers, and it's going to be very normal to see a slight variation. Well, we have an adjust offset feature where you're not adjusting the combustion engine, but you can adjust that and bring those two readings more in line to tighter tolerances, right? Here's some competitive differences. Now, at Raypak, I'm very proud to say that we don't do predatory marketing. We are never going to go out and disparage our competitors. We are, however, going to point out significant differences. And so that's what I would like to do right now. So one of the primary differences is that we're measuring that O2 sensor is going to be mounted in our vent stack. A lot of our competitors measure it on the combustion chamber. Now, here I will say outright that this is a little bit counterintuitive, right? If we have our O2 sensor mounted on our exhaust stack where condensing is happening, right? That condensate is a liquid, it's going to come rolling back down that heat exchanger. You might think that that is a wet reading. That is actually by industry standards considered to be dry O2. And you're going to hear this term more and more often. Well, how do you do your O2 monitoring? Well, we have dry O2 measured in the stack. Some competitors out there are measuring wet O2, and that's on the combustion chamber, maybe at the top of the tube sheet, next to the igniter, next to the rectification probe. So there's a primary difference, okay? So again, it's counterintuitive. That O2 sensor is mounted on our vent stack, and it is considered dry O2. Very, very significant difference. With our product, we are running that O2 sensor. Whenever that boiler is running, it is measuring O2. It is 100% of the time active on a call for heat. And that is not true with all competitors. So more to follow on that in just a moment. So these are significant differences that we like to point out and highly specifiable. Some of the benefits, we have less parts. We have the ability to calibrate that sensor to the analyzer that you just saw on the previous slide. It is important because now your combustion analyzer is in very close proximity to that of your O2 sensor. So you're going to have a reading that is going to have a tendency to be more accurate to that of your combustion analyzer. So that O2 sensor, being a short distance away, is going to be able to see a much more accurate or likely to be in alignment with what's going on at the O2 sensor, as well as that probe of your combustion analyzer. You can say that if I need to replace that O2 sensor over time, it's going to be a lot lower in temperature and it's going to be a lot easier to replace. More to follow on that. Temperature fatigue can be a factor. Condensing. Now, what would kill an O2 sensor would be that moisture, right? Think about the O2 sensor on your car. Where is it? It's on the exhaust header. And when you first start up that vehicle and that engine isn't up to temperature, you'll see that liquid coming out of the exhaust pipe. Some people think, well, that's water in the gas tank. No, that's the system that is not heated up yet, and you have that natural condensation process. So just remember in your mind's eye that it is acceptable to put an O2 sensor in the exhaust stack, just like they do in vehicles. Ferrari, Porsche, Ford, Cadillac, Lexus, they all have O2 sensors in the exhaust, right? So this is not a new concept for us. Proprietary, we are using an off-the-shelf O2 sensor. This is very affordable. Now, I also brought up the fact this morning that I live in a very small town in the Midwest, town of 2,400 people. There is I'm not promoting one automotive company, auto parts store over another, but there's a Napa auto sales in our small town. 2,400 people, Napa. I walked in and they had the O2 sensor behind the counter. So yes, we have replacement parts over time if you need them. But I want to talk about the availability and supply chain issues that if you have a proprietary O2 sensor, this is something that can be discussed with our engineers and mitigate these types of issues. And long life expectancy. We launched O2 monitoring and O2 track back in 2019, prior to my arrival at Raypak, and we launched it on the XVers product. And from 2019 moving forward, there has not been one O2 sensor failure. So we already have a track record with this product, something that we need to talk about. So long life expectancy. Now, in terms of comparing our competitive differences, I did give a check mark to one of our competitors, but this kind of goes back to how they use that O2 sensor. One of the competitors, they operate and monitor that sensor during a call for heat for 4 hours, and then they shut that sensor off for 10 hours. Provided that call for heat is still going, then they turn that sensor back on, run for 4 hours, turn back off for 10 hours. So they're suggesting that they're going to get longer life expectancy, but of course you are. You're not running it 100% of the time. Of course you're going to prolong the life. And we're talking about tens of thousands of hours of runtime as a life expectancy over the course. Think about how many times you may have changed your O2 sensor in your vehicle. Probably not that often. And these are the same type of O2 sensors. Okay. If you'd like to revisit this slide, this is slide 22. If you want to talk about competitive differences at the end, we can come back and revisit this slide. So as Bob mentioned earlier, we're going to have this as a standard feature on the item stock in our 3PL. But if you have a unit that's already existing in the field, or maybe there's some inventory that we're cycling through that doesn't already feature O2 monitoring, we have the ability to supply this O2 monitoring kit as a retrofit kit. That kit includes a sensor, all the necessary components to get you up to speed and get this field installed. And we'll take a look at what that looks like here in just a minute. Now, as we mentioned earlier, and this is important, one of the features is that this O2 sensor is going to be pre-mounted in this vent pipe that comes with the kit. So if you order the unit standard, the standard unit in the 3PL will come with this piece of vent pipe as well as this O2 sensor already retrofitted in, ready to go. If you order the retrofit kit, you're going to get this piece of vent pipe with the O2 sensor already installed. And it is located, or rather it is mounted at a 10-degree angle. So if condensate were to occur in that vent stack, remember, this is a condensing appliance. Of course, it's going to be it has the likelihood to be in a condensing mode, which is absolutely fine. And for that reason, we have mounted that sensor at a 10-degree angle so that it doesn't wick or draw that condensate into the unit. This again is how we're getting this very long life expectancy of O2 sensing. What you might also notice on this vent pipe is that we have a port here for your probe type combustion analyzer, or rather the probe for your combustion analyzer. So again, as we said, it's going to be in very close proximity to see your combustion analysis O2 sensor reading with that on the boiler where it's sensing O2. And again, this is one of the primary differences that we are talking about. I think I'm going to go ahead and pause here. I'm going to unmute and see if we have any questions. Let's see, unmute all participants. Okay, so I have unmuted everybody. If you have a question, just please unmute yourself and fire away. We can address any questions you may have thus far. I'm not at all surprised. I explained that very well. All right, little humor there. Okay, we'll keep moving forward then.
Does it require a software update for the retrofit on the actual controller, or is there already a screen in the core that's there that we just have to access?
That's a great question. Was that Jared? Was that you asking that question?
Yes, it is.
That is a fantastic question. We're going to cover that here shortly, but we are including the SD card for that software update. So we'll cover that more thoroughly here in a few slides, but that is an excellent question. Thank you for bringing it up. Okay, now as we know, these high efficiency products, these category 4 appliances, they have a variety of materials that we can vent with. Stainless steel, any UL 1739 approved, excuse me, UL 1738 approved systems, polypropylene, CPVC, PVC Schedule 40. So it's going to be important to understand that no matter what, we're always going to utilize this piece of supplied vent material with the O2 sensor, and from there, you are going to transition to your adapter, whether you're going to polypropylene, PVC, or CPVC. And again, the adapters are optional. The starter piece would be what I would consider this to be. So if you're getting a retrofit kit or a unit with it already installed, you will have this piece, and from there, you will order your optional adapter to transition. I want to make that very clear that we're not including the transition piece if you're going to a different vent material. The O2 sensor, again, this is an off-the-shelf sensor. It's actually a 6-wire sensor. Interestingly enough, these sensors have to heat up a little bit for them to register correctly. So one of the wires is for heat, one of the wires is for heat ground. There's a signal wire, a signal ground, and one of these wires is not used. So again, a very simple 6-wire sensor. They're not all created equal. Sometimes if you ask for an O2 sensor at your automotive, you might run into a 4-wire sensor. So again, these are very specific. Yes, they're off the shelf, but there are multitudes, different types of O2 sensors. It's like going in and getting a gallon of milk. I can get whole milk, 2% milk, 1% milk, and so on, right? So again, not all O2 sensors are created equal. It's going to come with a printed circuit board and all the mounting hardware. And then, of course, if it's a retrofit kit, it's going to come with a separate installation and operation manual. And I will just tell you that this retrofit kit is very, very simple. Now, look at all the simple hand tools that are needed. Nothing exotic. This would be very, very easy for your typical contractor to retrofit. And I will tell you, we're going to be there right by your side, walking you through this, okay? And I want to give you a small taste of what this retrofit is going to look like, okay? I don't want to go through each and every step. That would maybe bog you down in minutia that you don't necessarily need. But I do want to give you an example of what, if your customer says, hey, I see the benefits and the merit of O2 sensing, I would like to retrofit for this particular boiler project. And I think the benefit also would be leading you back to remote. So now you can go onto your remote and say, let's see what my combustion engine is looking like with O2. And you can get a health check for the combustion of that system. So again, I think retrofit kits are going to be very good for those maintenance facilities, hospitals, school districts, where maybe they want a first line of defense via remote to monitor what's going on with that combustion engine. I think it's a very good, plausible thing to do. So steps 1 and 2 were electrical lockout, tag out, and shutting off the gas. But this is a illustrated guide with very standard points, right? So we're going to guide you through this narrative step by step with these visual guides on how to install this sensor. So again, I just want to give you a couple of examples of, if you're doing a retrofit kit, here's the guide that you're going to be looking at. Devin and I are going to be going through this in our ILC. We can come to your location, show you how to install these. Very, very easy to do. Now, having said that, there are quite a few steps. All of them are simple, but numerically, there's quite a few steps to go through. And I don't want you to be overwhelmed. One of the steps is remove a grommet. One of the steps is cut the grommet and reinsert, right? So numerically, you're going to see quite a few steps with this visual guide, and I don't want you to be overwhelmed. They're all simple. It doesn't mean that it's difficult. Just because we haven't done it before doesn't make this a difficult process, and we're going to be there right beside you to walk you through it. So again, numerically, there are quite a few steps, but they're all simple. One of the steps is putting the decal on the unit when you're done, right? So we'll be there, we'll walk you through it if you're interested in the retrofit kit. Very easy to do. Okay, let's talk about the software compatibility. Jared, this is your question. And again, thank you for bringing that up. Right out of the gate, right now, after, as a unit leaves the factory, it's going to be ready software-wise for your screen and your updates. That O2, that hot O2 screen will be active. It has the ability to be active, all right? So it makes the retrofit kit plug and play, because again, right now we're going out the door and we are providing an SD card to do an upgrade if you're doing the retrofit kit, right? If you're doing a retrofit kit, the retrofit kit comes with the SD card that allows you to update the software, and we'll show you what that looks like as well. And you have a couple of different options. Maybe you just want to plug in the SD card, or if you don't, you can use a QR code scanner and it will link you to that software update remotely, right? So a couple different options for getting that software screen. Now, keep in mind, right now, this product is backfilled only to the XVers+KOR. The XVers+KOR has a 7-inch touchscreen. Don't confuse it with the other sizes of touchscreens, because those screen updates have a different set of installation guides, right? So again, very specific to a 7-inch screen on that software update. Again, very simple visual narrative on how to do that update and update that screen. And of course, once you plug it back in and power it back up, it is self-extracting. And once it does that self-extracting, you will see the alpha character of R physically move from the upper left-hand corner down into the middle. And then you'll default back to your home screen, and you'll know that software update was complete and updated. I'm going to go ahead and pause again here, see if there are any questions, see if Jared, if that answers your questions right there. I'm going to unmute everybody, so if you have a question, go ahead and unmute. Okay, we'll keep going. And then troubleshooting. Honest to goodness, troubleshooting on this is very, very simple. If you lose power at the board, you're going to know it, because there are some diagnostic lights on that printed circuit board. If the O2 sensor, for whatever reason, is bad or is damaged, you'll know it, and I'll show you the maintenance side of this real quick. And then if you have an O2 sensor fault, we'll talk about replacing that O2 sensor moving forward. Now, for maintenance, there is a, well, let's talk about this one first. If for some reason the board loses communication with the O2 sensor, we don't lose operation of the boiler. Combustion and operation of the appliance is still going to continue. We're just not going to be registering that O2 data. I think that is a very, very good thing. And hats off to our team for making it this way. Just because we might have a loss of communication with the sensor, and if my boiler is still functional, we want to continue to provide heat as needed. I think that's going to be important. From a reliability standpoint, if we ever see a sensor reading that is 1 full percentage point away from, perhaps on our combustion analyzer, we're registering it at 4.6% right here. And on our board, we see a variation of maybe a reading of 3.6% on the unit. At that point, being 1% off from our analyzer, that would be an indication that our sensor may need to be replaced. Okay, so very, very easy to do. So here I just have an example of 1 full percentage point. Okay, so if I had 4.6% on my combustion analyzer, if it was reading 3.3%, then I'm well within, or rather over, my 1% tolerance, and it is time to replace that O2 sensor. Okay, but again, we're expecting multiple years of service, tens of thousands of hours of service from these O2 sensors. As a retrofit kit, if you're ordering it as a part to retrofit kit, this is going to fall in alignment with our typical warranty. I have it highlighted on the XVers+KOR. So if you order the retrofit kit, it is 1 year from date of installation, right? And of course, when you do that startup, that will be when that date of installation takes effect. And again, be very easy to document at that point. So again, typical warranties are in place. There's no change to that at this point in time. Okay, before we get to the end, I would ask, my only ask from the day is that you would take out your smart device, pull up your camera, and scan this QR code. This is just an optional survey, if you would be so kind. Scan it, type in the event ID, and give us your feedback. Hey, this was good. This is what we'd like to see more of. What else should we talk about? This is, again, your opportunity to provide feedback through this optional survey. I'm going to hold this here for just a minute. Okay. And then finally, there is my email. This webinar has been recorded. We will post it to our raypaktraining.com site. It takes a little bit of time for us to edit it and then get it up on the website, but this will be edited. If you're interested, you're welcome to reach out to me. There's my email address. I would be more than happy to send it to you as a PDF. Okay, now, having said that, that was our final slide. I'm going to go ahead and make sure everyone is unmuted. Okay, unmute. So we'll go ahead and be open forum, question and answers. Let's go ahead and take any questions or revisit any slides.
Are they available on the smaller units with the smaller touchscreen down the road?
Oh, very good question. So one of the things I love about Raypak, and I think it's a standard across the industry, is once we're successful with this, we backfill it to other units. So I think it would be a normal expectation to expect this to be backfilled to XVers, to be backfilled to XVers+L. At this time, we do not have, or rather, I do not have any tentative launch date for that. Next up in our queue is next up in our queue is to continue on with O2, but make it our tracking trim so we can actually adjust and compensate for colder weather, warmer weather accordingly. So I would say, to answer your question directly, yes, over time it will be backfilled to other products, but I do not have any specifics at this time.
Okay, thank you. I got one
Question,
more.
Mike. Thank you.
You're welcome. One more. On the when you're ordering the new one, plug and play. Now when you order the options, is still the option to order polypropylene or CPVC?
Agreed. So let me restate that.
Was it D32 or D33?
I'm sorry, go ahead. I interrupted you.
Was it D32 or D33 that we used to order before?
It was C as in Charlie, C13.
Oh, okay.
Let's go ahead and go back to that screen here. Yeah, so I'm just going to pop this screen back up. And the C13 option is going to be standard. Let me finish the narrative here. On all units stocked in our 3PL, it is going to be a standard feature. If you're ordering a configured item, you would need to add this as an included, or rather as an optional feature. So it is not standard with the unit by default, but it will be standard in the units we stock in our 3PL.
And that is stainless. So this is Bob Ellis to explain the termination on this C13 is going to be stainless. You can get the Poly Pro adapter for it.
Well stated, Bob. Thank you. Okay, other questions? Well, very good. Well, on behalf of Raypak, I want to first say, Bob Ellis, thank you for joining us and providing some insight for sales. Very much appreciated. Always appropriate. Tim Badger, if you're listening, thank you for all your help and support in marketing. We have a fantastic product management team led by Joey Kruger, vital and instrumental in guiding this process. So hats off to Joey Kruger, Tim Badger, Bob Ellis. This is truly a team effort on behalf of Raypak. Again, feel free to reach out if you want to email me, and I'll put my email back up there. And I would be glad to send you the PDF copy. And with that, we will close out today's webinar. And again, on behalf of Raypak, thanks for joining us.